Hi, I'm Marissa, a scientist at Taudia. Today I'll walk you through how to run the SPLASH assay for ultra-sensitive protein detection. You can run this in your lab with standard qPCR equipment and just a couple of hands-on steps. You'll need your SPLASH kit and protocol, pipettes, a plate that works with your qPCR system, optical seals for your plate, tubes for dilutions, and a magnetic rack. You'll also want a wash waste container that complies with your local requirements. I would also recommend a multi-channel pipette, reagent reservoirs, and some paper towels. The first step is preparing a calibration curve using the lyophilized protein standard. This will allow us to calculate the absolute picogram per mil of our samples. I'll reconstitute the standard with sample buffer, then make a 7-point 4-fold serial dilution. I'm using strip tubes, but any plastics like individual tubes or a plate will work as well. First, I'll add sample buffer to each tube. Then, I'll make my serial dilutions, starting with the reconstituted protein into S1 and diluting 4-fold into each tube in turn, all the way to S7. The final tube is our blank, or our background. It just contains the sample buffer. Now, I'll plate each standard into the 96-well qPCR plate in duplicate. I'll reconstitute the checkpoint calibrator protein and add it to my plate. When it's reconstituted, it has a concentration that falls between S4 and S5 to help validate my standard curve. Using checkpoint is optional, but it's a good QC check. Now that my standards are plated, I'll add my samples. If you're using serum or plasma, you'll want to dilute it 4-fold using sample buffer. If you're using cerebral spinal fluid, you'll want to dilute it by 25 to 50-fold. Next, I'll prepare the probe mix for my plate by adding each antibody conjugated probe to a tube of probe buffer. Now, I'll add my probe mix to each well. This can be done using a single-channel pipette, or you can use a multi-channel pipette and a reagent reservoir. I'll cover the plate, and I'll incubate it on the bench at room temperature for 2 hours, or overnight at 4°C. During this incubation, the target-specific antibody probes will form immunocomplexes with the target protein. After the incubation, we'll do a magnetic bead wash to isolate the immunocomplexes. First, I'll shake or vortex the beads to disperse any clumps. Then, I'll add 50 microliters of beads to each well. Just like in the previous step, you can use a single-channel pipette, or you can use a multi-channel pipette and reagent reservoir. Then we'll let the plate incubate for at least 5 minutes from the last bead addition at room temperature. Once our incubation is finished, we'll place our plate onto the magnetic rack and make sure it's well seated. The rack will pull and hold the beads with the attached immunocomplexes so that we can wash away any other materials. I'll start the wash by holding the plate and magnetic rack together and flipping it 2 or 3 times into the waste container. Next, I'll add wash buffer to each well. In this case, I'm using my reagent reservoir and multi-channel pipette, but you can also use a single-channel pipette. We'll decant again into our waste container. We'll repeat the wash step once more. After we decant the second wash, there might be some liquid left in or on the plate. I'll tap the plate and magnetic rack together onto some paper towels to dry the top of the plate, which will help the optical seal to adhere. If you prefer, you can also decant the wash buffer with a pipette while the plate is on the magnetic rack. After washing, I'll keep the plate on the magnetic rack and add Amplimix to each well. Amplimix contains all the reagents we need to measure our immunocomplexes by qPCR. We'll seal the plate with the optical seal and then put it in our qPCR system to run. After the run is complete, I'll use the software from my qPCR instrument to export the CQs. I'll take this data and import it into Taudia's analysis software, which will use the standard curve to calculate the absolute picogram per mil of each of my targets. If you want to learn more about Taudia's Splash benchtop workflows, check out Taudia.com.